The reaction below was studied and the following data were obtained. What is the rate law? So the rate law is going to be a proportionality constant multiplied by the concentration of the iodide to the m power and the concentration of OCl to the n power. Now, let's answer the other question. Calculate the value of the rate constant. Well, to calculate the value of the rate constant, we first need to know m and n. So how do we do that? Well, for I, let's choose a place where I changes and OCl doesn't change. So the rate, 7.91 times 10 to the negative 2 molarities per second is going to be equal to a K multiplied by 0.12 molarities to the m power times 0.18 molarities to the n power. We're going to divide everything by the second experiment, so that's 0.060 times 10 to the negative 2 molarities per second, and I wrote the wrong number, is 3.95. And then here we're still going to have a K. This becomes 0.060 molarities, and this 0.18 molarities to the n. So now that we have this, we notice that we can cancel these two. These cancel out as well. These units cancel out. And so what do we get? Well, we get 3.95. Let's see if that's half. This is about half, so this is about 2 equals to 2 to the m, which means that m is 1. Now that we found that, we can do the same process for the other concentration. So for the other reactant, let's see. We can find a place where the reactant changes. So let's use the first and the third. So we're going to say 9.88 times 10 to the negative 3 molarities over second. This, I think, is a little bit confusing here. I think this is all in the denominator. And is equal to K times the rate for that 9.88 for iodine, which is 0, sorry, not the rate, the concentration. And that's to the power of 1, so we don't have to write anything, and 0.090 to the power of n. And we divide everything by the first experiment, which is 7.91 times 10 to the negative 2 molarities per second. Here we still have a K, and now this is 0.24 and 0.09. Wait, what did I say? I'm looking at the wrong one. 0.12 here and 0.18 here, and these are all in molarities, and this is to the n power. So let me just make sure I wrote it correctly. It seems like now I have, so I can simplify these things, and then we can find n, because we can say what we can say 1/2 here to the n to the n is equal to, let's see, 9.88 times 10 to the negative 3. We want to divide this whole thing, we want to divide it by 7.91 times 10 to the negative 2. And then the numerator, we also want to multiply it by 0.12. And the denominator, we want to multiply it by 0.03. And so we get about 1/2. So we can say that n is also 1. So now we can find the rate, because now we can rewrite the rate law. Sorry, we can find the rate constant, because the rate law is now just this, to the first power and concentration of OCl minus to the first power, so we don't have to write the 1. And now we can say that K is equal to any rate, so let's pick the last one, 7.91 times 10 to the negative 2, divided by these two guys at that point, at that data point. So that's 0.24 molarities and 0.090 molarities, and this is molarities per second. And so let's see what we get. 7.91 times 10 to the negative 2, close that, divided by, and I think you read this as an 8, so let me, okay, divided by 0.24 times 0.09, that's going to be about 3.66. Two significant digits going to be 3.7, and it's going to be moles to the negative 1 and seconds to the negative 1, right? And calculate the initial rate for an experiment where both I and OCl are initially present at 15 moles per liter. Well, now we can rewrite our rate law, which has just become a function of the two concentrations, because this is going to be 3.7 m to the negative 1 and s to the negative 1. And now we can just put 0.15 molarities in both of these cases. And we will find, so this times 0.15, we will find that this is 0. Or we can use scientific notation, 8.2 times 10, and we approximated, times 10 to the negative 2. Let's see, one of the moles cancels out, and we have moles over second, which seems correct since we're calculating a rate. So now I just have to make sure that it is correct before I give it to everyone. And so what is this? This is a number 35. Number 35. And it is correct. All right, I hope this was useful, and happy learning.